Welcome to Stats Made Simple. Congratulations! You've successfully completed the first 30 days of our 365 Days of R Functions series. Now it's time to put everything you've learned into one real-life mini-project. Imagine you've just joined a university as a data analyst. The principal gives you a student performance dataset and asks you to answer several important questions. Can we solve them using only the first 30 R functions? Absolutely. Let's begin. First, we create our student dataset. We use the C function to create vectors containing student names, attendance, marks, and CGPA. Next, data frame combines all these vectors into one structured dataset. The rep function repeats values like gender and department automatically instead of typing them again and again. Finally, seek generates sequential student IDs. Our dataset now contains 9 variables. Great! We now have a clean dataset ready for analysis. Let's look at the first few observations. We use head and it displays the first 6 students. This allows us to quickly verify whether our data has been imported or created correctly. Similarly, tail shows the last 6 observations. This helps confirm that the entire dataset looks correct. Now let's understand our data. We run str, students. It tells us that our object is a data frame. It also shows every variable along with its data type. For example, student_ID, name, gender, and department are character variables, while attendance, math, statistics, programming, and CGPA are numeric variables. This is extremely useful before starting any analysis. Now let's generate a quick statistical summary. Summary, students. The output provides 6 important statistics for every numeric variable. For example, if the average mathematics score is 84.5, it tells us the overall class performance. Similarly, the median shows the middle score, while the quartiles help us understand how the marks are distributed. How many students are there? We use NROW and it shows 20, which means our dataset contains 20 students. How many variables are recorded? We use NCOL and it shows 9, meaning there are 9 columns describing every student. Instead of counting rows and columns separately, we simply use dim and. The output is 20 rows and 9 columns. Now let's calculate the average mathematics marks. Mean, students $math, suppose R returns 84.5. This means the average mathematics score across all students is 84.5 marks. Next, median, students $programming, suppose the output is 87.5. This tells us that half of the students scored below 87.5, and the other half scored above it. Let's calculate the total programming marks. Sum, students $programming, suppose the output is 1708. This is the combined programming score of all students. Max, students $CGPA, returns 9.6, meaning the highest CGPA is 9.6. Similarly, min, students $CGPA, returns 7.2, which is the lowest CGPA. Let's find the attendance range. Range, students $attendance, suppose the output is 84.96. This means attendance varies from 84% to 96%. Length, students $student_ID, returns 20, confirming there are 20 student IDs. Sort, students $math. The output displays mathematics marks in ascending order, making it easier to identify the lowest and highest performers. Unique, students $department, returns statistics, computer science, mathematics, and data science. These are the 4 departments in our dataset. Table, students $department, returns 5, 5, 5, 5, meaning each department contains 5 students. Suppose the university wants to audit scholarship records. Sample 1. NROW, students 5, randomly selects 5 students. Every execution produces a different sample. Seek 1, 20, creates roll numbers 1, 2, 3, all the way to 20. Representative, statistics 5, creates statistics, 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 statistics. This saves time when creating datasets. Paste, SMS, 1001 to 1020, SEP equals, creates SMS 1001, SMS 1002, SMS 1003, and so on. Subset, students, math greater than 90, returns only students who scored above 90 in mathematics. Instead of searching manually, R instantly filters the required records. Which, students $math greater than 90, returns the row numbers where these students appear. This is useful for indexing and conditional operations. Suppose admissions for next year haven't started yet. We can simulate expected marks using R norm, 20, mean equals 80, SD equals 10. The output contains 20 randomly generated values that approximately follow a normal distribution. var, students $math. Suppose the output is 64.42. Variance measures how spread out the mathematics scores are. A larger variance indicates greater variability. SD, students $math. Suppose the output is 8.03. This means student scores typically vary by about 8 marks from the average. IQR, students $programming. Suppose the output is 10.5. This tells us the spread of the middle 50% of programming marks. It is also useful for detecting outliers. Finally, boxplot, students $programming. The boxplot summarizes the distribution using the 5-number summary: minimum, first quartile, median, third quartile and maximum. Any unusual observations appear as separate points, making outliers easy to identify. In this single mini-project, we created a dataset, explored its structure, generated summary statistics, counted observations, filtered records, generated random data, measured variability, detected outliers, and visualized the data. Most importantly, we successfully applied the first 30 R functions to solve real-world analytical problems. This is exactly how data analysts, statisticians, researchers, and data scientists use R in practice. Congratulations! You've now completed your first real-life R mini project. If you enjoyed this video, please like, share, and subscribe to Stats Made Simple. Comment below with another real-world dataset you'd like us to analyze. And don't forget to join us for day 31 of our 365 Days of R function series. Master R, one function at a time. See you in the next video.